Hi everyone, here are your notes for section 1.2. Again, I'm just sending a quick reminder that if you need to pause this video at any point in time to get caught up, jot something down, feel free to pause me. But let's go ahead and get started. So we are now going to be looking at specific things that can happen to all these basic geometric figures that we talked about. So last section we talked about points, lines, and planes. So now we're going to focus just solely on lines and more likely line segments for the next few sections. So what we have here is what we call the ruler postulate. And the ruler postulate states that the points on a line can be matched 1 to 1 with the real numbers. So for example, if you had a ruler, you would line up the numbers that are on the ruler with what you wanted to measure it, and you could measure it. Now if we were in class, I'd have you all grab a ruler and we'd measure things around the room, but we are in the middle of the COVID pandemic right now, so we won't be touching rulers. But I do highly think and recommend that if you don't know how to measure with a ruler yet, you might want to go out there and do some practice with it. So your coordinate that matches up with the number on that real number line is called the coordinate. So the coordinate is the real number that corresponds to the point. Okay? And then you use that when you do all your measurements using a ruler. But we're not going to do that, and we're going to focus specifically on the distance of line segments. So the distance is the absolute value of the difference of the coordinates of A and B. And just like in section 1.1, where we use different symbols to represent things, like we use the double arrow to represent a line, we used a single line with no arrows to represent line segment, and we used a line with one arrow to represent array, we do the same thing for distance. So if I were to see somewhere on a worksheet, oops, I don't want that, just two numbers right next to each other, with no symbol on top. That means I want to find the distance between A and B. So point A and point B, or otherwise known as finding the length from point A to B. Okay, so no symbol above. No symbol above means we're talking about finding the length or the distance between 2 points. Okay? All right, so here's our segment addition rule. Our segment addition rule tells us the following. If AB, so the length from A to B, plus the length from B to C is equal to the length of A to C, then B must be between A and C. So again, pause as necessary. I'm going to keep on going because I only have 15 minutes until I have to start paying for this app. If we have our line segment, and I have A to B here, so the distance from A to B plus the distance from A to C should equal the whole entire length, right? If this was 2 and this was 3, then the whole entire thing would be 5. So A to C's length would be 5. This only works when B is directly in between, not necessarily in the middle, but in between points A and C on the same number line. Okay, so that's your segment addition postulate. So we can use our segment addition postulate to solve for some easy lengths of a segment. So here we are told that from M to N is 5, from N to P is 18, but we're asked to find the length or the distance, between, oh my goodness, I can't even spell distance right. Go back, there we go, distance between, sorry for my chicken scratch, M to P. So we know that from M to P, it would be equal to 5 plus 18, which is 23. So my final answer tells me that the length of M to P is equal to 23 units. Simple as that, adding two numbers. So now let's do the flip of that. What if I was given the whole entire length? So from F to H is 36, but from F to G is 21, how do I find this unknown length? Well, 21 plus what gets us to 36? Well, how do we do the reverse of that? Well, GH is going to be equal to whatever 36 minus 21 is. I put it below because that's how I visualize doing subtraction. 6 minus 1 is 5. 3 minus 2 is 15. So my final answer in official form says that the length of G to H is equal to 15. Simple as that. Don't make it any more complicated than that. So now I'm going to have you try one on your own. Here we have A, B, C. AC is 10, BC is 12. What is the length of AC? Hopefully you got your AC to be 22 by just adding 10 plus 12. Let's try another one on your own. A, B, C. A to C is 25. B to C is, let's go with 18. What's the length of AB? Hopefully what you did is you took 25 and subtracted 18 from that and got an answer of 7. So AB is equal to 7. Okay, let's move on to the last concept in section 1.2, which is about congruent segments. Congruent segments are line segments that have the same length. So congruent means that they have the same length or the same measure. We have some labeling that we do to show congruency, just like with our symbols for shorthandedness. Let's say I had line segment AB here that was 5 units long. And directly below it, we had line segment CD that was also 5 units long. To show that those two line segments are congruent, we put little tick marks. I'm going to get rid of the 5 and the 5. We put little tick marks on the lines to show congruency. So those tick marks mean congruent. Another way to write this out is we could say that line segment AB is congruent. That's our symbol for congruent right there, is congruent to line segment CD, which also means that the length of AB is equal to the length of CD. Those are different ways to write it out. Your lengths can be equal. 5 equals 5. But our line segments will never be equal because they're never exactly in the same location on the plane. In this case, one's higher than the other one. So don't ever say line segments are equal. Their lengths are equal. The line segments are congruent. Okay, so here looking at this example, using the provided ruler, determine whether the line segments are congruent. So using our ruler postulate, let's go ahead and find the lengths. J to K, J matches up with 0. It looks like K is about at 7.5. So that puts that at 7.5 units. P matches up at 4.5. N is at 12. So if I wanted to count how many units, I'm going to work backwards. That's 1, 2, 3, 4, 5, 6, 7 and a half. So are they congruent? Yes, they are congruent. How do we write the notation down? I'm going to put line segment JK is congruent to line segment PM. So that notation might be what's new and a bit challenging in this lesson. All right, now let's do some math. Here we go. In the diagram, points V, W, X, Y, and Z are collinear. So collinear, remember, means those points are all in the same line, which they look like they're all in the same line in that diagram. We are told that V to Z, so I'm going to do some labeling here. V all the way down to Z is 62 units. X to Z, so the length of X to Z is 30. And the lengths of WX, X, Y, and YZ are all the same. So they're congruent. So I'm going to put a little tick mark there to show congruency. So now find the following lengths. Well, before I even worry about what's happening on that left-hand side and what I need to find, let's fill in all the unknowns. So let's focus our attention right here at the 30. Notice that x to y and y to z must be exactly the same length. Well, I know that the two of them together makes 30, which must make each of the individuals 15, because they're the same. And since wx is also the same, it would also be a 15. Which means from w to z, 30 plus 15 makes 45. Now can we find the rest of this length? If the whole thing is 62, from here to here is 45. 62 minus 45 gets us 5. 12 minus 5 is 17. So that makes VW 17. Now I have all the information I need to solve the stuff over here on the left-hand side. So now let's go over there. W to x, we already have that labeled, is 15. V to x, V to x, V to x, we have to do some math there. So V to x, get rid of this, is from here to here. So 17 plus 15 gets us 32. So 17 plus 15 equals 32. V to w, we have listed as 17 already. And then w to y is right here, is 215, so that would make us get 30. Okay, so make sure that you can use all those concepts of segment addition and congruent lengths to solve for unknown parts like this. You may now move on to your next activity.